All right, let's talk about it. If you're a developer, you know that a microservices interview can feel like walking a tightrope, right? The questions are tough, the stakes are super high, and your answers, well, they pretty much define you as an architect. Today, we're going to break down the 5 absolute toughest questions you will face, and we're going to give you the patterns to answer them like you've been doing this for decades. Let's dive in. So, picture this. You're in the hot seat. You've just laid out this brilliant system design on the whiteboard. The interviewer leans in, and you know this is the real test. They're not just asking about a specific line of code, they are probing your fundamental understanding of the deep architectural hurdles that come with distributed systems. And that's exactly what we're going to do in this explainer. We're not just going to talk about the problems. Oh no. We are going to arm you with the patterns, the strategies, and the crisp, powerful answers that show you haven't just read about these challenges, you've mastered them. Okay, first up, the absolute classic, the big one. In a monolith, a database transaction is atomic, right? It's all or nothing. It either works completely or it rolls back like it never happened. But with microservices, well, things get a whole lot messier. So the interviewer throws this real-world scenario at you. You've got an order service, an inventory service, and a payment service. They all have to work together. But what happens if the payment goes through but the inventory service fails? How do you stop yourself from charging a customer for an item you don't even have in stock? This question really tests if you get how to keep data in one piece in a world that's built to fall apart. And the answer you give them is the saga pattern. See, instead of one giant, risky transaction, a saga is a chain of small, independent, local transactions. Now, the magic here is in what we call compensating transactions. You can think of them as these super precise undo buttons for every single step. So if the payment service fails, a compensating transaction automatically kicks in to tell the inventory service, hey, put that item back on the shelf. Now, you can run your sagas in 2 main ways. First is choreography. It's kind of like a dance, where each service listens for events from the others and just knows what to do next. It's awesome for simple workflows, but man, it can be tough to track what's going on. The other way is orchestration. This is more like a conductor leading an orchestra. A central service, the orchestrator, tells each microservice exactly what to do and when. It's way easier to monitor, but that conductor can become a bottleneck. It's all about understanding the trade-offs. So when you're in that interview, here's your killer one-liner. I'd handle distributed transactions with the saga pattern, preferring eventual consistency. Boom! That sentence shows you know the primary solution and its core trade-off. And that trade-off, eventual consistency, leads us perfectly into our next big challenge. All right, let's keep going. If our transactions are distributed all over the place, it means our data is too. So the next logical question is, how on earth do we keep it all in sync? And this is the immediate follow-up you should expect. Every microservice owns its own little database. The user's profile lives over here, in the user services database. Their order history lives way over there in the order services database. So if a user updates their name, how do you make sure that change shows up everywhere it's supposed to? You know, the key here is to completely shift your mindset and embrace something called eventual consistency. Unlike the immediate, strict consistency you get with one big database, we have to accept that there's going to be a tiny delay before all the different parts of the system are synchronized. The system will eventually become consistent, and you know what? For most things, that's totally okay. And to manage this, we've got a whole toolkit of patterns. We already talked about sagas, which are perfect for this. Then you've got something called CQRS. That's a mouthful. It stands for Command Query Responsibility Segregation. It's just a fancy way of saying we create separate, optimized models for writing data versus reading it. It's great for performance. And of course, you absolutely need rock-solid monitoring to spot any inconsistencies and have processes ready to fix them automatically. And there it is, your sharp, confident answer. You state the core model, eventual consistency, and you list the main patterns you'd use to make it happen. This shows a super practical, realistic approach to what is a very, very complex problem. Okay, so our data is flowing, it's consistent, but how do we make sure only the right people and the right services can actually access it? Let's talk security. Think about it. Putting an authentication check inside every single microservice would be an absolute nightmare to maintain and keep secure. The interviewer is looking for a centralized, scalable, and most importantly, secure pattern. How do you lock the front door and then make sure that identity is trusted all the way through the system? The industry standard solution here is an API gateway. Just think of it like a bouncer at a club. It stands at the single fortified front door. The gateway has one job: check IDs, and make sure you're on the list. Once it verifies who you are, it hands you a trusted stamp, and you can go talk to any of the internal services. This is amazing because it means your individual microservices don't have to worry about security. They just have to trust that any request coming from the gateway is legit. So how does this work in practice? Well, the modern standard is to use something called JSON Web Tokens, or JWTs. As you can see in this flow, the client app asks an authentication server for a token. The server gives it a digitally signed token, and the client just includes that token with every single request it makes. The API gateway's only job is to check that the signature on the token is valid. This is so powerful because it's stateless. The gateway doesn't have to look up anything in a database. It makes the whole system cleaner and way more scalable. Now, this is the full package expert-level answer. It names the core pattern, the API gateway. It names the technology, stateless JWTs. It names the framework for managing permissions, OAuth 2. And then, for bonus points, it adds a best practice for security between your services, mutual TLS. That's where services prove their identity to each other. This answer shows you're thinking about the entire security picture, from the user all the way down to the deepest parts of your system. Okay, we have built a secure, consistent system. But let's be real. Services are never static. They have to change, they have to evolve. So how do we do that without breaking everything for our users? This is a deeply practical question. Your mobile app right now is talking to version 1 of your user service. But you're about to release version 2, and it has some breaking changes. How do you support both the old app and the new app at the very same time? So here are the most common strategies. The one you see everywhere is URI versioning, just sticking /v1 or /v2 right in the URL. It's super explicit, easy for everyone to see. Some people prefer using custom headers or even query parameters. Now, the most restful way, the one that kind of best follows the original principles of the web, is using something called the accept header, but honestly, it's often the most complicated to get right. The key here isn't to say one is best, but to show the interviewer that you understand the pros and cons of each one. Here's the expert take. You start by listing the main strategies, which shows your breadth of knowledge. But then you add 2 absolutely critical best practices: using semantic versioning to clearly communicate what kind of change you're making, and using deprecation headers to gently warn clients that an old version is going to be retired soon. That shows you're thinking about the clients, not just the server. All right, we've reached the final challenge, and trust me, it's a big one. How do we actually guarantee that a system made up of dozens of tiny moving parts actually works reliably? With a monolith, you can kind of just spin up the whole application on your machine and run some tests. But you can't do that with 50 different microservices. So the interviewer wants to know your strategy. How are you going to ensure quality without getting bogged down in tests that are slow, brittle, and take forever to run? The standard answer, and it's standard for a very good reason, is the testing pyramid. It visualizes a really smart, layered strategy. At the bottom, you have this massive base of fast, cheap unit tests that just check tiny pieces of code in total isolation. As you move up, you have integration tests that check if a service can talk to its database correctly. Then you have contract tests. These are so crucial for microservices. They make sure that one service hasn't made a change that will accidentally break another service that depends on it. And finally, at the very, very top, you have a tiny number of slow, expensive end-to-end tests that check a full user journey. And it is so important to be clear on the difference between the 2 main layers. A unit test works in a complete vacuum. It checks one function, and it fakes everything else: the database, the network, all of it. An integration test does the exact opposite. It checks how real components work together, like verifying if your code can actually write to and read from a real running database. Getting this distinction right is key. This answer is strategic and it's comprehensive. It shows you're not just going to write one type of test over and over. You have a balanced, cost-effective strategy that prioritizes speed and reliability. And that is exactly what a hiring manager wants to hear. And there you have it. From distributed transactions all the way to testing, we've gone from data consistency to security to versioning. You've walked through the entire gauntlet, and now you are armed with the patterns and the precise language you need to prove your expertise. So remember this: knowing these patterns is not enough. The real mark of a senior architect is understanding the fundamental trade-off. Microservices give you incredible scalability and independence, but it comes at the cost of this immense complexity we've been talking about. Showing that you can thoughtfully navigate that complexity, that is how you ace the interview. So the real question is, are you ready to manage those trade-offs?